it up by 1. So where it used to be -1, it's now 0. Where it used to be 1, it's now 2. And now if you look at the green curve, it is at 0, it's 2. That's what this says. At pi over 2, it is 1. When pi, it was here for cosine, it is here for 1 plus cosine, so that's the 0. At 3 pi over 2, which is here, the cosine is 0, 1 plus it is 1. And the final one in this table is 2 pi, and there it is back to 2 again. Here is 2 pi, the graph is back to 2 again. Now this graph tells me more than this table. This table only gave me 4 or 5 points to plot. This graph gives me all the ones in between. So as I gradually go, the angle goes from 0 to pi. The distance drops from 2 to 0. As my angle rotates from 0 to pi, the radius, that's what that is, r, is dropping from 2 out, which is here, down to 1 out, down to 0 out. That.
Whoa.
Okay? And then from pi up to 2 pi, the radius grows again from 0 to 2 symmetrically and does that. Now if you turn your head sideways, what shape is it? Heart. Does anybody know the word for heart attack? When somebody gets cardiac. Yeah, this is a cardioid. cardioid, because it's a heart shape. Okay, it's Latin. Cardioid. Oid.
There's supposed to be 2 I's.
O-I. Cardioid. O-I-D is oid. Cardioid. Cardioid. Okay? And so that shape is a cardioid. And there are other cardioids. Here is another curve. R equals theta. Its graph looks like this. As theta increases, r keeps increasing. So r is 0 in the 0 direction.
Wait. Oh, question.
And there is the graph. That's spiral.
Well,
As the angle theta keeps increasing, the radius keeps increasing. You have a question there?
so like the R, like the distance from the x-axis?
Distance from the origin.
Oh. Wait, but
There, each of these radial lines, at a given angle, we measure out the distance r equal to theta. Okay?
Whoa.
And that gives you a spiral.
What?
I will show you when we go downstairs an applet which has, I think it's 14 different pretty curves in polar coordinates and has their equations. And using the polar coordinates and a polar equation, you can plot all these different pretty pictures. One other let me show you is r equals, say, sine of 2 theta. Okay? First of all, a rectangular plot looks like this. So here is sine, okay? It goes up to 1 and down to -1. Okay? The double angle, this would normally be 2 pi. However, because of the 2 in there, that's only pi. So when theta is pi, sine of 2 pi is back to 0. When theta is pi over 2, this is sine of pi, which is 0. Okay? And here is 2 pi. The graph of this looks like a 4-leaf rose. As the angle goes from 0 to pi over 2, that sweeps out this quarter of the plane, right? And the radius goes from 0 to 1 back to 0. It goes around like that. Okay? Let's skip this piece and go to that piece. Between pi and 3 pi over 2, we are in this third quadrant. We're going from pi to 3 pi over 2. And the radius again rises from 0 to 1 and back to 0 and gives me a nice symmetric loop there too. Okay? Now we have these other two pieces. On those, the radius is negative, which is a strange concept. It means go backwards. So the angle is growing from pi over 2 to pi. We are from here to here, and we are going from 0 to 1 to 0 again, but in the negative direction. And so as the angle goes here, we make a loop down there. And in this piece, down in this quadrant, we have to go backwards, and we actually make a loop up here. And so to actually trace this thing, it goes like this. How many of you doodle? This is a beautiful doodle. Okay? Typical doodle picture people make. And this is a what's called a 4-leaf rose, or a daisy, or a four-leaf clover, sometimes it's called. Okay? And so that is a 4-leaf rose. If you put a 3 in there instead of a 2, you get another rose with different bumps. Okay? And so when we go downstairs, I'm going to show you how to pull up the applet and take a look at all these polar curves. Okay, time to go downstairs.